Welcome to a deadly episode of the Into the Impossible podcast featuring the Pluto Killer himself, Professor Mike Brown. This is the astronomer who forever changed our solar system's map, tearing down childhood certainties and rebuilding our cosmic understanding from scratch. From teaching geology without ever taking a geology course to hunting a mysterious ninth planet lurking in the outer dark regions of our solar system, Mike's career reads like a scientific thriller. Today we're asking some uncomfortable questions for this murder suspect. Was it really necessary to kill Pluto? Is there still a massive hidden planet, some 5,000 times bigger than Pluto, haunting the outer solar system? And what happens when scientific discovery collides with public sentiment? Mike spent decades searching for Planet 9 after demoting Pluto, and the irony isn't lost on him. His detective work with the Subaru telescope has narrowed down the search to the constellation Taurus, potentially uncovering the fifth largest planet in our solar system. Buckle up for astronomical controversy, scientific detective work, and the raw human journey behind reshaping our understanding of the cosmos. These are some of the deepest mysteries in the cosmos, and this is the Into the Impossible podcast.
Mike Brown, thank you for making the trip all the way down from Pasadena.
Great to be here.
It is so nice to have you here. You're giving a talk today entitled Planet 9 from Outer Space. It is obviously reminiscent of a famous movie that probably 99% of my audience is too young to know. But the abstract, which is fascinating, astronomers have been predicting and searching for planets beyond Neptune for almost 180 years. That's how it begins. It's time to give up. Time to give up the search. 180 years is a long time to come up with nothing, right?
And everybody who's been searching and proposing the existence of planets, they're always wrong. They are usually wrong for a sort of embarrassing.
Mm-hmm. And you are known, or you were known on the platform formerly known as X, now known as Twitter. No, other way around. Was Twitter, now is X. Pluto Killer, but you're not on there. If you go there, you won't find Mike. You'll find him, but he's not active. But names are really important to you. Pluto Killer. Mike, wouldn't it have been simpler just to keep Pluto, and then you wouldn't have to waste the last 20 years searching for this other planet? And we could have had 9 planets. We already had it when you started.
I never actually anticipated that the research that I did would lead to Pluto being demoted. I knew as soon as that the Kuiper belt was found, these objects beyond Neptune started being discovered, it was pretty obvious that that's what Pluto was, that Pluto deserved to be classified with those instead of with the planets. But I never thought that the astronomers would have the guts to do it, or that the public would go along. I never thought this was what I was doing, and yet it was the right thing to do. Like, we now describe the solar system correctly instead of this weird way where we had planets and this funny little thing called it a planet, even though it was part of this thing's era. So now we at least have it straight.
Yes.
Pretty happy with that.
We have a fun game. We're Jewish in our household, and there's always a temptation to find things that could be kosher but are not. For example, pigs, they have cloven hooves. This is very important for astronomical purposes, people. Pigs have cloven hooves, but they do not chew their cud. So one of my kids asked, well, what if you trained a pig to chew his cud? Then he'd have both of these so-called kosher symbols. Other ones are fins and scales for fish and other things. And, crustaceans, you can't get the shrimp on the Barbie in any way. What types of ways could a clever astronomer, a malicious astronomer perhaps, evade the current definition that was used to basically kill Pluto? What could we do, say, reshape the orbit? Let's talk first of all, what are the definitions of the planets? I know you're probably, you're not sick of this at all, but tell us the 3 characteristics, and then how could a malicious, malevolent, Constantine Batygin type figure, how could they evade these things for objects that already exist?
First, let's talk about the definition of planets. And the first thing I'm going to tell you is that the definition is dumb. There's a reason for that. We don't do definitions of classes of objects in astronomy very much. Like, what's the definition of a star? Star. I mean, you know what a star is, right? And so there's some boundaries that like, what's a star versus a brown dwarf versus a something else, and that's okay. But we understand the concept. Galaxies. Yeah, there are galaxies, there are dwarf galaxies, there are mega galaxies, and we understand. We don't have to have a 3-part lawyerly definition that says, oh, are you a galaxy? You have this many stars. Oh no, there's one fewer. You're not of the galaxy. Sorry, bud. We don't do that. So why did we have to do that in the solar system? And the only reason we had to do that in the solar system, we didn't have to, but the only reason it happened in the solar system is because it really was of public interest whether Pluto was a planet or not. The only reason there's a definition is to answer the question about Pluto. And actually, at the time, it was to answer the question about Pluto and about Eris, the object that we found that was more massive than Pluto. What is it to be? And so, everybody wanted to know, is this a planet? Is this not a planet? What are we going to do? What's a planet? And so astronomers at the time felt the need to write a definition. So the 3-part definition that I do not like and hope that everybody forgets as soon as I say it is that for a planet in the solar system, you have to go around the sun. You have to be
round.
Mm-hmm.
Check. I'm there.
And you have to have cleared your orbit. That's the one that people like to argue about because it's not very obvious what that means. And then, once you have a lawyerly definition, you get lawyers involved who are like, well, we have this asteroid that might be about to hit the Earth. Clearly, the Earth has not cleared its orbit, or so it's not a planet. Wow. It's like when you just send the lawyers home and you realize that it's the concepts that matter. What those 3 things are trying to tell you is that in our solar system, there are a small number of gravitationally dominant objects that are different from the other things. And the ones that we know, there are 8 of them, and they are big. They're in circular orbits. They are not messed with by all of the myriad small things that go flitting around the solar system. There are tons of asteroids and comets and other stuff that just go in and out of the planets. They go flying everywhere. If they come close to a planet, they go ejected in some other direction. The planets don't care. They're the big bullies of the solar system. That's really all that definition is trying to say, is that there are dominant objects that have cleared the orbits, even if you don't have to define what cleared the orbits mean.
And this is for you. This is your gift. This is delivered by gravity. This is an honest to goodness fragment of a minor body. Yep, hold it up.
Came from is this from the Cielo meteorite in Argentina?
Campo de Cielo.
Yeah.
Very good. You didn't even have to taste it.
Good.
Normally I taste it. I give it to Joe Rogan. He smoked it or something. That one is highly radioactive.
The first one, the Campo de Cielo.
Campo de Cielo, the field of the heavens. Now, you cannot get these anymore by exporting from Argentina. They've forbidden it. It's actually a crime. But you can get them if you are like Mike or me and you have a .edu email address. I give them away to my lovely audience on briankeating.com/edu. If you don't have an edu email address, try your luck at briankeating.com/list. And that joins you up. You'll get information about the meteorites, even if you don't win. But the reason I bring these up is because these objects really are unsung heroes, I think, of the solar system in some ways. And the planets, the planets that make the most sense and the planets that seem to appeal most to you are these big giant gas giants, the ones that were explored by none other than Galileo is my hero. We did the first ever audiobook of Galileo, the dialogue, with Fabiola Giannati and many other luminaries, Jim Gates, Frank Wilczek. Galileo was no stranger to hunting for planets. I mean, he actually accidentally discovered Neptune, right?
He actually saw it.
Yes, right.
Discovered is not quite the right word.
Right. He could have discovered it if he used the tools in your book. And what I love about your book is that you actually describe not only what it's like to be an astronomer on a day-to-day basis, but what it feels like. And you start off as a student, as a kid, actually in Alabama growing up, right?
Yeah.
And then growing up, what fascinated you. But you talk about the tools, the technology, and so forth. This is a plate taken by the late, great Margaret Burbage. I'm wondering if you can spot the planet. I think there's no planet in that. It's a galaxy. She was teaching Vera Rubin how to do rotation curves back here in the 60s. Talk about what drew you, what kept you in astronomy through those long years, using the Schmidt telescope, using the tools that would later become your stock and trade. It was much harder back then, right? Today's kids like Petitians and so forth, they got it easy, right?
They got it easy. The Vera Rubin Observatory is going to do it all for you. You don't have to do any of that stuff. But it's still, even though the technology has made it easier, it's the ideas that are the exciting part. You're exploring. This is a part of the solar system where no one has ever been before. Nobody's ever seen before. And you are trying to figure out how to be the first person to do it. And when we first started with these photographic plates, a little bigger than this, 14-inch square photographic plates, you would get one of these photographic plates and you can stick your eye up to them, and the universe is just an amazing place. These days, again, you just call up whatever your favorite website is and you can see all these pictures. We went back and found some of our old objects on old photographic plates, and you circle it with your felt tip pen there, and you circle it there, and you think, this is it. These are the first photons from this object that we think ever got collected on the Earth, and you're the first person to see it. there is nothing more exciting than that. Like sitting at you're sitting at the telescope. You're sitting at the computer. You're not sitting at the telescope. You're not seeing the photon, but you're sitting at the computer looking at these images coming in. You see this thing moving across the sky that no one's ever seen before. How can it be better than that?
It's so visceral. I mean, I talk about that in my first book. I talk about how, you can't feel what it was like to discover the Higgs boson or to discover, to do a myriad of things in biology and anything else. But you could feel exactly what Galileo felt with a tiny telescope looking up at the moon on a clear night or Jupiter. Yeah. You can see the same stars from Pasadena as he saw mostly. You can see the same 4 Galilean satellites. He named him after his funding agency. He was a pretty smart guy. But he got into a lot of trouble, and a lot of his work is dominated by what I would call, and what Mario Biaggioli, who's a historian of Galileo and Renaissance science and history of science, he calls kind of the patronage kind of almost like a grift, that Galileo didn't release tools. Even his friend Kepler, who's a contemporary of his, how to build a telescope, how to use the telescope, what he saw through it. He released kind of the instruction manual, the Sidereus Nuncius. And I think it was smart. And Mario makes the case that he was kind of being a little too clever and now get into trouble. But you had a run-in with some Spaniards. I want you to go over this subject. I know you. It's an amazing story. And I just want you to maybe, if you can, talk about how, as you describe in the book, what Galileo would do to avoid the kind of prying eyes and this early espionage that took place in astronomy, and how it still goes on to this very day. So let's talk about the Spaniards and the discoveries of the 2005, 2006 time period.
It's a crazy story that if you told me the story or tried to, I saw it on TV or something, I don't think I would believe it. We were deep in our survey of the outer solar system. Every night, the telescope up at Palomar Observatory would open up, would scan a region of the sky. We would take 3 pictures over about 3 hours, look for something that was moving. That morning, I would have the data transmitted down to me, and we would look for things. And we would look for things. Mostly the computer would pick out the first round, and then I would vet the next round of things, and then occasionally found real ones there. And there was this one period that was just an amazing period in my life, where we found, over the course of about 3 or 4 months, we found three of the 4 largest objects known in the outer solar system. So it was a couple days after Christmas, it was this object now known as Haumea. We called it Santa. Yeah. We always have code names, as that was Santa because it was found out for Christmas. A couple days after New Year's, there was Eris, which is the one that's more massive than Pluto, which code name Xena, Warrior Princess. And it says, of course, that was the code name. And then just a couple months later was what I found right after Easter was Easter Bunny, which is now Makemake. And we had been finding ever increasingly large objects, and we were good. Our rule was from discovery to the first scientific publication, we had our rule that it had to be 6 months. We could not be any slower than that. Because we thought it was important to get that information out there, but we also thought it was important to learn something about the object, so that our first announcement was not just, gee whiz, we found something, but hey, here's an object, let us tell you about it. Here's a story. And these always got pretty big press coverage. So we wanted to be able to, tell a story.
Was it in part to avoid, what your former colleague Richard Feynman said, the problem of being the biggest fool yourself and avoiding confirmation bias? Was that part of it?
Not in that sense, because at no point was there any worry that the object didn't exist. Once you see one of these objects in the outer solar system 3 times and then you go observe it 2 more times, like, it's there. There's no question of making sure you're right. At that point, we know it's there. But we knew we had one chance to get attention from the public for the outer solar system. And we wanted to tell a good story that people resonated with. Just the chance that they would wake up in the morning, open up their newspaper and learn something cool about the outer solar system and be excited about it. As opposed to opening up their newspaper and somebody says, yeah, we found something at 52 AU.
Can you convert that to millions of miles, please?
So we would tell the story about how it got there, why we named it, and the names were important for those reasons too. So this is the long version of the story. So we were doing this, and we were being very fast, but we did have people mad at us for taking 6 months to announce things. There is a
subculture.
Yeah, there's a subculture in the solar system, and for good reasons, where announcements get made immediately. You discover something, you announce it immediately, because it's a comet that might be disappearing, or it's a near-Earth asteroid that might destroy the Earth tomorrow.
In 8 years.
Yeah, so you need to announce those quickly. Makes sense. These objects did not matter. They were not going anywhere, but we were still trying to be in a hurry. But there were people who were still mad, and so we got a lot of pushback that we ignored mostly from those astronomers. In July of 2005, several things were going on. One, we had discovered 3 of these. This is tough. Where our 6-month limit was coming up on the first one we had found, and we have a paper almost done, and it was a super interesting object. It was shaped like an egg, like a squashed egg, rotating once every 4 hours. It had a moon around it, so we knew how massive it was. It was about a third the mass of Pluto. It was covered in water ice. If you looked at the spectrum of it, you could see the reflected light was precisely that of the water ice that you would get out of your freezer. And yet it had the mass of something that was a rock. So it was clearly like a thin layer of ice with a rock underneath, like the world's worst M&M, I think is what it was. So I was finishing this paper to announce this. And the other thing going on at the time was that my wife was 8.5 months pregnant. I took a day off to finish writing this paper, and she went into labor. Of course, that day, literally that day. Yeah. As I really think I would have finished the paper the next day. I think it's really true, because it was like just anyway. She went into labor. I sort of dropped that project and started this new project.
Yes, exactly.
For a couple of weeks.
Smart man, right?
And in the meantime, one of my graduate students, one of my postdocs, was going to a conference, and he was going to talk about this object. And he had written an abstract. He used the name. Our real code name was Santa, but we had like a computer generated name based on it when it was discovered. So it was like K0512. It was something about the day. Anyway, I don't remember what it was, but he put that in the abstract title. I'm like, why would you use, like, no one, it's an arbitrary thing. Why would you use that? Who knows? I woke up one morning when my daughter was 20 days old to a email from Brian Marsden, who was the director of the International Astronomical Union Minor Planet Center, which is where you send all of your...
That's right. One of my proudest accomplishments is getting this asteroid named after my mentor, Jim Simons. And you read, if you will, for the camera, Mike, who was the discoverer of asteroid that's now...
The discoverer. He's Clyde Tombaugh. Nice one.
Now, the connection is, of course...
Who discovered Pluto.
Right.
Which is not a planet.
The lunar planet. That's right. So we got this name for him, and we have one for Marilyn, his wife. And he was very proud of it, except he asked me immediately when I told him about it, being the hedge fund tycoon that he was, and especially with futures, he said, do I have mineral mining rights on the asteroid? And I said, if you can get there.
If you get there, the answer is yes. Absolutely.
So amid these two big bang moments, that you're having,
so I get this email from Brian Larson. He's like,
as a professor and a podcaster and a scientist exploring the boundaries of knowledge in the lab, I crave independent sources of knowledge and wisdom wherever I can find them. One of my go-to sources is The Economist. I've been reading it literally for decades. The Economist consistently delivers independent journalism for independent thinkers like you and me. But the best part for me is that their science coverage is nothing short of extraordinary. Just this past week, I was captivated by their deep analysis of the recent claims of quantum computing breakthroughs that could revolutionize how we process information. Exactly the kind of forward-thinking coverage that I discuss on the podcast and that I crave to expand my own intellectual horizons. The Economist's rigorous approach cuts through the noise and BS in a way that you can truly trust. And what sets The Economist apart is their Simply Science weekly newsletter. It's a subscriber-only exclusive benefit. Each weekly edition delivers beautifully written explorations of nature, technology, the cosmos, the human body, and all of this comes alongside stunning scientific photography selected and curated by their editors. I don't just do science. I love to explore complex ideas. The Economist analysis is a perfect complement. It provides the insight and clarity needed to navigate challenging intellectual terrain with confidence. And to get everything The Economist offers, The Economist is offering a special 20% discount just for viewers of the Into the Impossible podcast. To claim the special 20% discount, visit economist.com/Keating. Your pursuit of knowledge shouldn't end when this podcast ends. The Economist ensures that it doesn't have to.
I had been talking to him, and he knew that we had some things, and we were talking about how best to announce them because it was coming up soon. And he's like, I just got a report of this object. Is this one of yours? And I was like, nah, it can't be. I mean, no one else is doing a big survey like this. And I look at it, and it's a list of positions in the sky where it was detected. And I look, I'm like, oh yeah, that is Santa. That's our object now known as Haumea. And, my heart just sinks, and I feel terrible that somebody has found
scooped you.
They scooped us. And he was like, well, what do you want to do about it? I'm like, well, I mean, they discovered it. This is the way science works. You can, if you're holding on to something and somebody else announces it before you do, they're the discoverer.
You're a better man than me.
I mean, but
I would have got my lawyers in.
It's just
Pluto lawyers.
It's just the way it works. And I'm like, I felt bad, but I also felt like, oh no, these guys are going to announce it and they don't know anything because they had just put positions. They had just put positions like from the couple days before, and then gone back and found it in old data.
You knew the spectrum and the water ice, and
we knew about that moon. We knew about the mass. So they're going to say it's bigger than Pluto, which is not. It's because it's highly reflective. So they're going to think it's bigger than Pluto. So I wrote to them that morning. I said, congratulations. I actually have this email. I read this email back to myself. I'm like, oh my God, sometimes I can actually be like a
gentleman,
super nice. Wow. If anyone ever just declares that I'm always a jerk, I'm like, nope, only 99% of the time. Look at this email. I said, proof. It says, congratulations on this discovery. Amazing. I want to let you know so that, when you make the announcement, I want to let you know, we have a spectrum of it because we found it back here. We have a spectrum of it. It's got water ice. It's got a rotation period of this, and its mass is this. So it's only about a third the mass of Pluto. Super interesting object. I also said in this email, let me know when you come up with a name, because we'll want to name the moon, which we discovered. So we get to name the moon. We'll want to name the moon something that follows in whatever theme you come up with.
I do have to say, because I have a lot of young people that listen to this podcast, a lot of young scientists in training, graduate students, postdocs, in addition to 21 Nobel Prize winners. But the scientific ethics is not taught. We just don't teach it. I don't remember it being taught at Caltech when I was there as a postdoc. But the point being, there comes a time in every graduate student's life when they'll have some crisis of confidence. Are they doing the right thing? Should they do something else? They'll have some issue that will come up, and it's not always as big as this. But going through this without any training, the integrity to do that is very rare. You're joking about yourself, but it is rare. So can we teach that to our students? Is it important to have some? I mean, the medical school teaches ethics, the business school, the law school teaches ethics. Why don't scientists teach ethics?
It's a really good question. I mean, it comes up more often than you would guess as a scientist, and even as a graduate student, as a young scientist. I am often having these conversations with my students about, let's step back for a minute and think, is this really the right thing to doing, and should we do this? But it's not. There's no
guidebook. There's no handbook. Just like being a parent, right? So getting back to the story, the reason that this story takes a really devilish twist is because of what happens next, right?
Yeah.
How'd you find out?
Yeah. I think in another email from Brian Marsden. This is now Friday morning. I'm operating on 2 hours of sleep in the past 20 days.
Baby rest.
I get another email from Brian Marsden. He says, what about these other two? Are they yours also? And I'm thinking,
oh my God,
what's going on? It's a ridiculous story. But these three objects, we had been tracking with an automated telescope in Chile just to learn about them. And that automated telescope, the data were not publicly posted, but the logs were posted that had the names and the locations. And one of the names was K0520, whatever that name that my postdoc had publicly posted. And somebody had Googled that name, found the website that had the logs, and then realized the positions where we'd been looking. And once you have to know the object. If the position that we point to is our precise
to the arc second
every single night for 3 months, you know the orbit of the object as well as we do, because that's how well we know the orbit of the object. So Brian realized that somebody had submitted all of these as discoveries that day. And I was like, he's like, what do you want me to do? I'm like, hold on.
Let's hold on.
So this is not like I have independently discovered it. This is like I discovered your website that had it on it.
Right.
So I'm like, hold on. Let me figure out what to do. And we decided on Friday morning, I decided to go to my office for the first time in 2.5 weeks. And I went to my office and I was talking about it. I'm like, we need to do a press conference today and announce these objects
On a Friday
afternoon when there was some crisis at the International Space Station and some presidential, all these things, like it's
raining and pouring.
It's when you announce that, that you stopped being your wife or something. I don't know. So I called people at JPL, like, we need to do this right now. And they're like, well, we can do it on Monday. I'm like, nope, we can't wait for the sun to go down. These positions are not all there. So if somebody actually went to the sky and got an image of it and said, I found it, then it just gets a little complicated as to what this means. So like we have to do it before the sun goes down. I mean, the sun was already down in some places. So, but still, we had to do it right then. So we did. We did it. We put together a press conference on a Friday afternoon on almost no sleep. My niece was staying with us at the time, and I called her up. I'm like, Lauren, bring me a blue shirt and a toothbrush and a brush.
Let that be a lesson out there. Right.
Yeah, I always be
prepared. Yeah,
I have the.
Now I often have is
absolutely true that I do. And we announced it right then, and it was exciting. Like on Good Morning America on Monday morning. Mostly, as far as I found out, learned because Diane Sawyer's middle name is Lila, which is the same as my daughter's name, and so my daughter was there. The first time my mother always ever saw my daughter was on Good Morning America. So it was all very exciting and everything was good. And like a couple weeks later, I got an email from, I'm going to forget his name now.
Spaniard.
No, I got an email from, at Ohio State, who ran the telescope, the SMARTS telescope in Kashile. Mm-hmm. And he said, I have found something weird. I'm like, okay, what? He said, well, the day or two before this announcement came out, I was looking at the logs for this telescope, and somebody sort of went through and not hacked, but went and found like the URL and changed the last word and like went through and basically downloaded and viewed every log that you had pointed at. And he said, I thought that was weird. And it was before the announcement happened. I was like, oh, that's weird. I don't understand what's going on. And he's like, so then I went and checked out where it was, and it was in Spain. I'm like, oh man. And then he said, and here are the IP addresses. And I had been corresponding with these guys, and we could trace it. It was first the IP address of this grad student who had been working with the guy who announced it. And then a little bit later, it was the IP address of the guy
of the advisor.
And, you can kind of picture what probably happened. Mm-hmm. I mean, what probably happened is that the grad student saw this abstract and like, weird, I wonder what that is, Googled the name, and it comes up. It does actually come up in that one thing, and it came up as a log, and then realized that he could find all these things, and then told the advisor. And then again, here's where maybe a little bit of ethical training would have been a good thing to do rather than announce that they had discovered it. I think it's also true that they were doing a search in the sky for these sorts of things, but they never had found anything. Well, and I think they might, it's not impossible that they actually had data that showed it. They just didn't know how to process it.
Oh, come on, Mike. So I couldn't help when I was listening to the book on audio, thinking of that famous line from that great scientific and philosophical giant Scooby-Doo that says, we would have gotten away with it if we weren't so greedy, right? They would have gotten away if it was just one object, but to claim all three?
So they didn't claim the other two.
Oh, who did?
So that was...
Same technique.
So they claimed the first one and said they had discovered it. And then an amateur astronomer in Germany who was mad at us already because of the whole hiding object place and works with them. I'm sure they told the guy there, and he went and figured out that you could find these other, and he's the one who submitted those two. They claimed that they had discovered it in good faith, and that just happened to be that the day before they were going to announce it, that they found the website and accessed it all and confirmed that it was there.
Right.
And I'm like, okay,
likely true.
What would have been the right response? Mm-hmm. The right response would have been to have said, oh, wow, we just found this too. And you probably contact the person and say, hey,
what you did.
We see that your K25 blah, blah, blah is the same object here. We were going to announce it. We're going to announce, who knows, at some point, but you certainly don't pretend like you never knew that this was all, that you had accessed all these data on the web. And so, I mean, obviously they never actually found it. They just did this. It's an interesting part of the end of the story. It got to be a big stink. Their institution disavowed them. They disappeared off the webpage for about a year. And now they're back. They're still working, active in the field, have never really gotten any pushback for having done it or anything else.
And so now these three objects, you already give the names. They're known as minor bodies or dwarf planets.
Dwarf planets, which is also a pretty...
Isn't that a great name? I'm sure a lot of people are unhappy with that for political reasons.
Dwarf planets are the ones that fit two of the criteria. They go around the sun and they're round. We actually had a word for that before that we used. These rest called them spheres. Actually, we had
I had one here. It's a minor body, a dwarf.
We actually used the word planetoid for a long time, which is good. It's sort of, it's like asteroid, it's planet, meteoroid, right? I think that's a much better thing. But these are all official dwarf planets. And then there's another whole issue on official versus unofficial dwarf planets. So these are all dwarf planets. It's Eris, the most massive one. And it really is the most massive. So if you take Pluto and you add the entire asteroid belt, that's the mass of Eris. Wow. Yeah. So there's Pluto, there's Eris, there's Makemake, which is crazy object, and Haumea, which is the most crazy object out there. I love these things. These are it's like your children.
Yeah.
They're all my favorite children.
Yeah, that's right. That's what my mom will say. I'll say, Mom, which is the four of us brothers, and which is your favorite? She's like, oh, that's like asking me to choose. Do I like my left hand better than my right hand? I say, Mom, you're a lefty. You're left-handed. Okay.
No, there's an answer.
We know the truth. She just doesn't want to say it. So Planet 9 is gone immediately. There's Pluto's gone. So we have 8 planets. Now you're on the hunt for Planet 9. Now you're working.
Really?
Not back then. I'm saying right now. Now we are. Let's fast forward because I do want to cover the topics of the talk and get into some hard-hitting, hardball questions from 2 professors. One goes by the name of Constantine, and I'll just get into that. When he sat in the hot seat that you are now in, you feel the heat, don't you, Mark? I asked him, the 3-body problem is insoluble. How are you doing your theoretical wizardry? We can't even solve the 3-body problem. How many objects are in the Kuiper belt or, Kuiper belt-like objects? How can he possibly do what he does? So first, I want you to kind of steelman what he does. The kind of theoretical predictions, is this all just computer mumbo-jumbo? You put in garbage, you get out garbage? Or is there really something behind what he does that we would classify as true hard science?
Yeah, so I'm going to start to when we first started looking for thinking about Planet 9. What we really were thinking about is, why are some of these objects at the very edge of the solar system, why are they all aligned? They all have orbits that swing off in one direction. It's an interesting thing. It's the sort of thing that forever, anytime anybody sees anything slightly weird in the outer solar system, they jump up and down and say, it must be a planet. And we did not want to be the 34th and 35th astronomers jumping up and down and saying that there was a planet. And
that's 180 years.
Being wrong.
Right.
Like everybody else. So, and we knew there weren't any other planets out there because that's just kind of a dumb idea that there's another planet. We all knew there are no other planets. So we started trying to do some calculations to understand what else could do that. And those calculations are really, you sit down and you write down you do the physics, you do approximations because you can't solve perfectly for everything, but you can solve for the general gravitational forces, how things interact, and you can write down the equations. And you can see what happens. And we did that. And we usually, when I say write down equations and I say it's Constantine while I watch, and nothing works. There's just no way to get these alignments going on in any way that we could come up with. And we spent probably a year trying to come up with these alignments. And then I think we both just ashamed of ourselves said, it could be a planet. It's like that sheepishly. And so we wrote down those equations, and they're not that hard to write down for the general behavior of how it would make kind of a thing like this. And it works really well. And then once you do that, the general physics equations involve some approximations that you have to check on. And so that's where the computer modeling comes in. And then you just do big, massive dynamical simulations where you put in all the planets, you put in a planet and you let them interact and you see what happens over 4.5 billion years. And it mostly follows those simple approximations that you made in your calculations, but the details are different. And you check to see if the details work out. And that's how then you carry forward, is mostly with the computer simulations to try to understand, okay, if we change the planet from being this massive to a little less massive, or a little further away, or a little closer, or in a more eccentric incline, how do those affect exactly what goes on in this part of the solar system? That's how we're really learning what it is we're looking at.
Constantine was sitting there. So he has, what does it say? One good turn deserves another, or turnabout is fair play, or foul play. I forget all these platitudes. But he asked me to ask you, bro, Literally, this is constant. I'm channeling him. Hi, bro. I will say in the Russian accent. No, I would say doing my best imitation. He says, bro, what about the systematics, though? THO, he spells it.
So my answer to him would be like, look, dog, the first and still the biggest public signature that there's a planet out there is these objects whose orbits all align in some direction. And interestingly enough, it's interesting. When we first proposed this planet, we assumed that within days, some other astronomer somewhere would have an alternative explanation. Astronomers are great at explaining things. You show them a plot and you say, can you explain this? They're like, yes, this is exactly what I predict because this, and that. And you're like, oh, no, I'm sorry, that's upside down. I show you the plot this way. This is what I meant to show you. And they're like, that's even better. It means this, and this. So, explaining things is easier. Mm-hmm. And so we assume there'll be explanations. And there are none. It's like some half-baked physics explanations, but of the physics of explaining why you would have this going on.
But technically in the cameras and the telescope, so look at the plate again. Were there things back, in the good old days, before Instagram? Were there tools, techniques that don't cross over, that don't translate from your days, licking the photographic films and the meteorites or whatever you geologists do, and developing things in the dark when you were a grad student up at Berkeley? What, kind of tools, techniques don't transfer through? What things are common between these enormous cameras on giant mountaintops? Or are they just so radically different? It's almost like two different sciences.
I feel like it's all the same. The technology is different. The science is the same. Like, okay, the technology of developing a photographic plate and scanning it and getting into your computer is different than getting a digital image in and doing that. But it's all the same. It's all the same stuff. And so that gets you back to the sort of what the systematics that he was talking about. It's all the systematics of, are you really seeing what you think you see? And, as in astronomy, we call it observational bias. If you were to look west one day a week and you saw the sunset, you couldn't really conclude that the sun sets in the west because it could be that it only sets in the west one day every week and you don't actually know what happens the other 6 days and you only look that way. If instead you looked everywhere over the course of the week and you only saw it in the west, then you know that you actually have something going on. And the suggestion, the only other suggestion that really that's been put forward about Planet 9 is that we essentially did that we only looked in one direction and we see these objects pointing it off in this direction and we didn't look in any other directions. And interestingly enough, we did look in the other directions too. Shockingly, we're not actually as dumb as you might think. And so, but it's a reasonable question to ask, and you have to calculate the statistics because in astronomy, you deal with clouds and this and that. So you have to make sure that you understand the statistics of where you've looked compared to what you've seen. And the statistics are good, but it's still something that people like to argue about because it's it's really the only other explanation. And it's just wrong. We have the statistics now very solidly in our favor that these things are aligned like this. And unless somebody's going to come up with another explanation for both this alignment and the 5 or 6 other things that we have also seen that really matter, unless somebody comes up with those explanations, they're like, there is no better explanation than a giant planet that we still haven't found in the outer part of the sun.
Tina, there is no alternative. This time is different.
So here's what I'd like to say.
Yeah.
It sounds weird to say, look, the previous 34 astronomers were all wrong and you shouldn't listen to them, but you should listen to us.
Those goofballs.
Because we're right. Like in our defense, the previous 34 astronomers were all wrong and we're right.
Yeah.
So you should listen to us.
That's right.
So you should.
You should listen to us for a reason.
You are right, and we're going to find it.
Another question comes from my friend and 2-time guest on the podcast, Professor Daniel Green, who's a professor here, theoretical physicist. I'm still on X, okay? I'm on Blue Sky too. I've only been called a Nazi once since going to Blue Sky. But you can ask questions. You can interact with Mike over there. You a Pluto Killer over there too?
PlutoKiller.com, because you can make your .com address. So.
Okay, cool. So you got a little merch. Get some merch over there, some swag if you go to that website.
No.
So you can ask questions of me at both locations now. I don't discriminate, but one of the best places is on YouTube where I'll be taking questions. But Daniel, my friend, my professor, colleague here at UCSD, in your book, How I Killed Pluto and Why It Had It Coming, he explains. It is a love story. It is. I mean, seriously, you talk about your love for...
I wanted to have that a love story, and my publisher would not let me do it.
Well, if Mark Manson can write, everything is after, a book about hope. You explain how you started your search for new planets in part because the tenure expectations at Caltech are so high, but then he didn't find anything until after getting tenure. I would love to know how he balanced high and low risk research to make that possible.
That's a really good question. I wouldn't say that I started it because tenure expectations are high. I mean, maybe you were expected to do exciting big science, but it's also, I started it because I could go explore the outer part of the solar system. And it's absolutely true. In the time before tenure, I spent a lot of time on these old photographic plates at Palomar, years taking these plates, developing. I did not do the developing. There were people who actually knew how to do this, and scanning them and looking for things that were moving. And in those years leading up to tenure, I found precisely nothing. And my tenure committee, they're like, it's okay.
It's all right.
Find nothing. But the important thing is to turn that into a scientific result. And so what you need to do is take that, do a careful calibration, and, explain what your limits are to what there could be out there. And it's just the correct thing to do. And I didn't do it. I didn't do it because at the same time that I was failing to find anything with the photographic plates, we had gotten the first primitive digital cameras, CCD cameras, and started putting them on this telescope at Palomar. And I realized I could either spend the next year or two calibrating the survey where I didn't find anything, or I could do 100 times better survey and find this.
Yes.
And so I'm just going to ignore my tenure committee's advice.
So I pointed out the wonderful, highly, integrity, mark of high integrity that Mike exhibited in this interaction with the Spaniard and the Germans. But this is an example of what I would call survivorship bias. I mean, you were successful, you are brilliant, and not everyone's a Mike Brown. So don't do that. Don't take this advice. And it's not financial advice, not tenure advice.
So look,
yes,
there wasn't anything wrong if there had not been anything there.
Right. To quote Obama, you didn't build that.
I knew there was going to be, I knew it was going to be that. I mean, I did know it was going to be, I knew that at that next level, we were going to find this.
Yes.
And I didn't know what we were going to find.
Okay. Next question comes from someone by the name of Deep Safe. Prevent, protect, preserve. I was actually going to call one of my kids that. He or she, I can't think of it. I thought NDT, Neil deGrasse Tyson, killed Pluto. How do you react to him claiming it, as he does everywhere?
He and I have a shtick. He will say it was my fault. He will say, "What is
the murder weapon?"
We haven't actually had. I haven't had to talk about this in a long time with him, so now I've forgotten exactly how we do this. But basically, he sort of says he was the sheriff and put out the search warrant, and I was the posse that brought him in. But when he's feeling a little bit of heat, he will definitely blame me for it. And when it's feeling a little bit, but he is very clear with what happened, and he was an important part of having that conversation start. And I'm not sure it would have happened the way it did had he not had started having that conversation.
Yeah, and there's no one better to kind of bring it to the masses. Yep. Yeah, he's a multi-time guest on the show. I'm going back on his show in a couple of weeks. I'll bring him your regards and a meteorite. Question from YouTube from Dystopian Prophet. That's actually pretty good. I wonder if he's friends with Protect, Preserve, Defend. Do you think Planet X has been around since the early solar system? And if so, what effects could have had on the solar system's evolution?
Yeah.
Ooh.
Great question. So first off, we don't call it Planet X. Planet X was actually a theory of
Vulcan, right?
The Vulcan was from Leverrier.
Leverrier, yeah.
So
who also discovered Neptune.
Discovered Neptune, and then did the one bad thing: never name your planet before you discover it, or you'll never discover it. So Vulcan, he called it Vulcan. Didn't exist. There is
Neptune,
no name.
Fine.
But Planet X was a theory of Percival Lowell, who was looking for a planet. Eventually, Lowell Observatory found Pluto, but he thought there was a giant planet out there. That was his actual theory. Doesn't just mean generic planet out there. So this is Planet 9. Mm-hmm. It's our theory.
Yes.
We get to name our theory Planet 9. The first part of the answer to the question is we don't know the answer. We don't know if it's been there forever. We don't know how it got there. But that doesn't mean we don't have theories for how it got there. The prevailing theory for how it got there is that it formed in the Uranus-Neptune region. It got scattered out early in the solar system, and it's been lurking, waiting to be found ever since then.
Now, does that tie into this definitional thing again? Because, if it's round, or if it's, an object that's round now may not be round tomorrow. If what if it was round, if it's 10 times the mass of Jupiter, but it has a chunk cut out of it because of a hit in contact with an asteroid? I guess the more relevant question is clearing out its orbit. I mean, what if it hasn't cleared out its orbit, but in a million years, which is a blink of as Neil deGrasse Tyson would say, it's the cosmic clock. Or Carl Sagan would say, actually, but Neil would ape him beautifully. Tell me, I mean, something that is a planet, could it not become a planet? Harkening back to the earlier, the provocative question I led off with, can the pig learn how to chew its cud?
And I think the answer, it shows you why lawyerly definitions are not the right way to do these things, right? It's just not the right way to do it.
Yeah.
It is true that the way that we know this planet exists is because it's cleared most of its orbit, and we see the parts that have not yet been cleared, and they will be cleared in 1 billion years. So we see that process going on. So it certainly fits that.
But you have to know the whole orbit, and then the orbit is relatively accessible, I guess, but to know that it's clear, do you have to scan the entire orbit? How does that work?
Do we literally have to see that there's nothing there? Yeah. Because we can see its effect and calculate that it's
where it is now.
And we don't care if it's cleared its orbit, in the sense that nobody's like, oh, damn, I can't remember if it's cleared its orbit, right? It might not be Atlantic. Oh yeah, it cleared it. Yay.
Now we're back.
It's just that it actually has, there's a simulation that I'll show in my talk today.
Yes.
Where we start with this huge body of objects out there, and they're almost all gone by the end of 4 billion years because it's cleared its orbit. This is just what's going on.
Okay.
So what else has it done? It's been clearing its orbit out there. A really interesting thing into this slightly deep dive into the physics of it. If you take a planet, and that's a little bit less than the mass of Uranus or Neptune, but you put it 10 or 20 times further away out there, it actually carries more angular momentum than the rest of the solar system. So it's the most angular item, and it's at a slight inclination to the solar system, which means that it is precessing the solar system around, but it's not precessing the sun. So it is changing the orbits, the orbital plane of the whole solar system, and not the sun. So that's maybe part of the reason why, according to us, the sun is tilted by about, I can't remember the number, 6 or 7 degrees compared to us. Maybe it's that we're tilted to the sun.
To the sun, right.
As a planet 9. Just that's, usually I say it doesn't do anything, but it actually does. It's actually a cool little effect that we thought about.
I want to talk about, some of the work that you started off with, which is looking for volcanoes on Io and all sorts of moons. What's the status there? And actually, before I do that, if you'll indulge me for, changing the subject mid-question, if we knew for sure that true exoplanets had no life on them, that we're alone, that we're it, do you still think the search for these objects, including the types of objects like Planet 9, has a scientific, moral, cultural relevance? Or, is it really hinging on the fact that, okay, we know we're going to find life one of these days? What do you think?
I think
I know it's not your field, but
no, but I think you're absolutely right that the idea of life drives a lot of what we think about when we think about exoplanets. I'm thinking back to a early stage when we were discussing a potential telescope in space that would try to look at planetary systems, and there was a debate on the team between, if you found one that looked potentially Earth-like, would you just devote the rest of the time that the telescope was in space to staring at that planet to learn what's for it? Or would you keep on looking to learn the diversity of things like that? And I was like, no, I want to understand the architecture of planets, systems, because I love the understanding how planets got there, how things get in the outer parts, the inner parts, everything else. And most of the other people were like, no, we would stare at that one Earth-like part. Right. So it's a strong current of what a lot of people are interested in. And I think it drives why the field of exoplanets is so large right now. And why, for example, going to Mars is one of the big things that we do in the solar system. And what's next? Going to Europa, what it might be like, maybe going to Enceladus, or might be. But if you think about it, even in our solar system, it's not the only things we do. We are sending missions to Venus to understand not life living down at the 1,000-degree.
Although some, Sarah Seeger, past guest, claims possibly.
But that's not true.
Okay. We'll do the debate next time.
So, but it's not why we're sending missions.
No.
Right? We're sending missions to learn about the planet, understand how planets work, because that's interesting. We're sending missions to asteroids to understand, sampling asteroids.
Tasting them.
Tasting them to understand the chemistry. And it's the chemistry that does lead to life, it's true, but not like we're going to find things that are out there. So if you took away that equation, I think the field would get back to being smaller, but I think it would still be there. I think there are a lot of people who are interested in, I love understanding the diversity in the architecture of planetary systems. It'd be cool to find something where there was life, like how exciting that is.
Yeah, of course.
But it's not
the main.
It's not the reason that I think it's cool. It's not the reason that I think even studying, I study Europa. I don't study Europa because I think I'm going to find bugs on it.
Although if they're there,
they'd be even better.
Let me know. I'll be the second to know, right?
But I
or some Spaniard will be the second to know. Talk about Pickle, Planetary icy ice chemistry laboratory.
My hobby lab is the Planetary Ice Chemistry Laboratory. Our logo is a pickle with planets inside a pickle jar with planets.
Well, you're a geologist, as far as I understand.
I'm actually an astronomer. I'm not even a geologist. Now I now live in a geology department.
Yeah,
but I'm an astronomer. You degrees in astronomy. I think about astronomy.
Kid, you were
when I go to sleep at night. This is. But I love geology. I love what. I mean, again, that's kind of my hobby too. I love these hobby things. But as an astronomer interested in chemistry of things in the solar system, the way you're looking at objects in the outer part of the solar system, and their conditions are different from anything that's on the Earth, and so they're often different from anything that's been done in the lab. And the way you make progress is you go do an observation, you find something interesting, and you'll go talk to somebody who has a lab, who studies these things in the lab, and you say to her, like, this is weird. I don't understand what this is, but maybe it's because this is happening at this temperature and this kind of radiation. Can you reproduce that in the lab, and does that work? And she'll say, that's a great idea, and I can probably get an experiment up and running to do that in like 5 years. And that's like, I'm not patient enough for that kind of things. And so I asked my department chair, and to his credit and discredit both, he's like, okay, you can have a lab. Start making a lab.
Wow. Forgot how nice it was to be a kid.
It's weird. And then I was like, we started getting it up, and we were starting to make things going. And the only reason it got enough funding to get going through its first couple of years is that asteroid. Jim Simons, the Simons Foundation, funded the first 5 years this lab, and that's it's so much fun. I not only am not a chemist and didn't have a lab, I had never actually been in a lab and didn't know what I was doing.
I decided not to give you a lab tour later on my labs.
It's really, I literally did not know what I was doing. We had to learn it all, and we do things differently than other labs because we learned, we just thought from scratch, how would you best do this, and sort of solve problems in different ways. Making measurements different ways, very specialist. It's so much fun.
It is fun. It's fun to get to play and not worry about things like tenure or publications and H indices or, this has been a great joy. Your book is phenomenal. It teaches you not only what it is like to be an astronomer, but what it feels like, what the challenges are, raising a family, growing up, and it's obvious you're a mentor to many, many, many because of your humanity and that you prioritize the things that you only get one kid, right? Yeah, some of us have more, but you only have one kid, right? We only have one set of parents, right? But the way that you describe what are the actual day-to-day challenges like, along with the hard science. I love the hard science, but I also like some of the memoir aspects of it too. Mike, I have a tradition here to ask one question inspired by the namesake of this podcast, or the name giver of this podcast, Arthur C. Clarke, a little bit about Jupiter and its moons and, some shenanigans going on out there. But he said many things. He said, for every expert, there's an equal and opposite expert. I could drop that on my department chair every so often. He also said, the only way of knowing the limits of the possible is to go beyond them into the impossible. That's the name of this podcast. That's where we get it from. I want to ask you, what would you do? You had 20 seconds with a 20-year-old Mike Brown. You get to go back in time, go back to Berkeley or wherever you were at that time, or, just around 21, 22. You get 20 seconds. What do you tell him to give him the courage to do as you've done, to go into the impossible?
I would tell him to explore and have fun and don't worry how it's going to work out.
That's awesome.
That's the right answer.
That's awesome. Mike, thank you so much. This has been a joy.
So much fun.
Now that we've whet your appetite for true scientific discovery, I want you to dive deeper, and you can do that by clicking here on this members-only video where Mike dives deep into the search for Planet 9 and doesn't shy away from all the pitfalls and perilous wrong turns that it's taken along the way. Click here for that, and please do join as a member. Your membership helps me keep this channel growing.